Okay, so this is question 11.61, question C. So we have to complete a chemical reaction to indicate a complete combustion with this alkane. So it's actually giving us a structure this time. So we have our structure, that's supposed to be a square, and we have our methyl group coming off of it. Sorry, this pen and this app don't love each other. So you can go around counting, you have to count your carbons, and you can count your hydrogens, but if we remember our formula, that a cycloalkane will have the formula CnH2n, it's actually a lot easier. So if you count every corner, so 1, 2, 3, 4, and of course don't forget about the carbon attached that creates the methyl group. You have 5 carbons, and then following the formula you would have 10 hydrogens. So our formula is going to be, for a complete combustion, is going to be C5H10 plus oxygen gives us CO2 plus water. So you do need to know that in a complete combustion reaction, it will always react with oxygen and produce CO2 and water. The question becomes, is it balanced? Okay, it is not balanced as of yet, so let's take inventory and see where we need to go. So on our reactant side, I have 5 carbon, 10 hydrogen, 2 oxygen. And on my product side, I have 1 carbon, I have 2 hydrogen, and I have 3 oxygen. So now what I'm going to do is I'm going to balance carbon and hydrogen first because they are easiest to factor. So I have 5 carbons on my reactant side. I only have 1 carbon on my product. So I'm going to add a 5 to CO2, and that will get us to 5 carbon. But of course we have to keep in mind that that 5 also applies to the oxygen, so 5 times 2 would give us 10, and we still have the oxygen from water. So we actually have 11 oxygen now. I'm going to do the same thing with our hydrogen. So I have 10 hydrogens on the reactant side and 2 hydrogens on the product side. So I'm going to multiply my 2 hydrogens on the product side by 5. Okay, and that will give me the 10 hydrogens. But again, that 5 applies to the oxygen as well. So let's count up oxygen again. So I have 10 oxygen from CO2, and I have 5 oxygen from the water. So I'm now left with 15 oxygen. So now the only thing that's not balanced is my oxygens. I have 2 oxygens on my reactant side and 15 on my product side. So basically what I'm going to do now is just do what is the common factor. So common factor with these two numbers, given that I have an even number of 2 and an odd number of 15, is going to be 30. So I'm going to multiply my reactant side by 15, okay, because 15 times 2 would give us 30, okay. So now I have 30 oxygens on my reactant side. Notice I haven't multiplied anything yet on my product side. So I have 30 oxygens. Carbon and hydrogen are still balanced simply because I've only messed with the oxygen on our reactant side. So this is a little bit easier to work with. You have 30 oxygens on reactant side, you have 15 oxygens on your product side. So the question becomes, what you need to multiply 15 by 2 in order to get that 30 oxygens complete. So because I have 2 products on, in my chemical equation, which one do you choose? Well, actually what we're going to do is we're going to double both. So I'm going to put a 10 in front of the CO2 and now the H2O. So now we should have, our oxygen should balance out. So 10 times 2 gives us 20 oxygens from the CO2, and then the 10 times just oxygen would give us now the 30 oxygen. Okay, that's awesome, but of course go back and see what else needs to be balanced because carbon and hydrogen aren't balanced anymore. Because we doubled everything, we're now dealing with 10 carbon and we're now dealing with 20 hydrogen. So now we have to backtrack and make sure that these are balanced. Now, the best part about this example here is that we're actually, on your product side, we're moving from product to reactant. It's actually halved. So what I mean by that is, on your product side you have 10 carbons, but you actually started with 5 carbons. On your product side you started with 20 hydrogen, but you're actually dealing with 10 hydrogen on your reactant side. So the only compound where we have carbon and hydrogen is in our cycloalkane here. So what I'm going to do here is I'm simply just going to add a 2 in front of it, and that's going to give us the 10 carbon, that's going to give us the 20 hydrogen. And so now we have a complete balanced chemical equation. It took us a little bit to get there, but we've got it. So a complete combustion of C5H10 would take 15, we would need 2 molecules of C5H10 plus 15O2 will give us 10CO2 plus 10H2O.